Hello, 8th grade math. We're here to do lesson 7.1, ratios and rates, found on page 343 in your textbooks. I encourage you to please open your textbooks and follow along with me. Your homework here is going to be page 345, numbers 3 through 26, but I'll come back to that at the very end. I'll give that to you again. On page 343, you see we have a couple definitions right off the bat. The first one being ratio. Ratios are something that we have seen before in the past, but just a reminder, they're a way to use division to compare two different numbers. We give the example as A over B. There's three different ways to write a ratio. Probably the most familiar that we use is looks more like a fraction. And remember that all fractions are really a division problem. And so there's that division piece coming in. We can also use a colon, or we can just use the word too. All of these can be read as A to B, A to B, A to B. And then the only other caveat is that B cannot be equal to 0. The reason obviously being that this is division and you cannot divide by 0. We've had a lot of discussions about that in the past as well. So that's a ratio. The next definition to talk about is equivalent ratios. Equivalent ratios are just two different ratios that have the same value. So for example, I have 9 to 5 right here, but if I were to multiply the top by 2, my numerator by 2, I would get 18. If I do the same thing on the bottom, multiply 5 times 2, I would get 10. And just as a little bit of fun here, I'll just show you on my calculator. My first ratio, 9 to 5, 9 divided by 5 is 1.8. It's going to be the exact same thing when I do 18 divided by 10. So both of them have the same exact value. Likewise, I could take either this guy or this guy and multiply them by something else. I'm going to go with my 9 again, and this time I'm going to multiply them by maybe, let's say, anything I want. I could say multiply them by 4. I could also use division. I'm not using division right now, but I could. I could do 9 divided by 3, for example. But if I do 9 times 4, I'm going to have to do 5 times 4 as well. Whatever I do to the top, I've got to do to the bottom, like I did in the first one. So 9 times 4 would be 36. 5 times 4 would be 20. And I can go ahead and try this division problem, 36 divided by 20, and find out that, yes, lo and behold, that also is 1.8. Because all three of these divide out to be the exact same quotient, they are equivalent ratios. That'll be important coming forward here. In example 1 on page 343, we have a little bit of a story problem. Please read along with me as I read it. It says that a ski resort has 15 easy ski trails, 25 intermediate ski trails, 7 difficult ski trails, and then, of course, the ones that I would take up on would be the 11 expert only ski trails because I am a very avid skier. Not really. The question that is asked is to write the ratio of intermediate trails to easy trails, and we're going to do that in 3 different ways. So first of all, I'm going to start by just kind of identifying what they're asking me to do. So the first thing that they're asking me to do is we're going to write a ratio of intermediate to, easy. So I'm just going to kind of set it up in kind of a fraction form here so that I know which ones I'm supposed to be looking at. And then I'm going to actually substitute what those values for those ski trails were. So there were 25 intermediate ski trails. I'm going to put a 25. The easy ski trails, there were 15. Now, it does ask us to write this in 3 different ways. I've only got it one way, 25 to 15. What they mean by write it in 3 different ways is let's come up with 2 equivalent ratios for 25 to 15. One way that I can do it is I could divide both of these by 5 because 5 is a factor of both 25 and 15. When I do 25 divided by 5, I get 5. And when I do 15 divided by 5, I get 3. So 25 to 15 is the same thing as 5 to 3. You can pause that and try that on your calculator. I will not do that this time around, but if you don't believe me, go ahead and do that. Go ahead and pause and just try. And then, unlike last time, I'm going to use my second ratio here to find my next equivalent ratio. In other words, what I'm going to do is I'm going to take my 5 and my 3, and I'm going to multiply each of these guys by the same thing. I'm going to choose it multiplication, and you can pick anything you want to multiply it by, as long as you do the same thing on top and the bottom. I'm just going to keep it simple, and I'm going to do times 2. I'm going to do times 2 on the bottom as well. 5 times 2 would be equal to 10. 3 times 2, 6. And all three of these, again, don't believe me, go ahead and pause it, divide these out. 25 divided by 15 is going to be the same thing as 5 divided by 3, which is the same thing as 10 divided by 6. They should all come out to be 1.67 when you round to the nearest hundredth. Moving on to the next page, then, page 344, we have another vocabulary term, which is rate. A rate is simply a ratio with two quantities of different values. We see rates a lot, and in fact, I'm going to these maybe weren't the best examples for me to come up with, because these actually would be better examples of unit rates, which I'm going to talk about in just a little bit. But a rate has two values. I got 35 and 1, but notice each of them have a specific unit that it's measuring. So the first one, we see this all the time. This is like a speed limit sign on the side of the road. Speed limit 35. That's 35 miles per every 1 hour you drive at that rate. Or if I were to fill up my gas right now, it's pretty cheap. I might be able to get it for $1.89 per 1 gallon. My unit here is dollars. I know it's not like a labeled word or anything like that, but it's a symbol this time. But my unit is dollars here. My unit down on the bottom is gallons. In example 2, I have another story problem. It says that lightning strikes about 100 times for every 1 second around the world, which is kind of an incredible thing. So every second that goes by, there's 100 lightning strikes throughout the world. That's what that's saying. About how many times does lightning strike around the world per minute then? Now, I know that this would not be hard for us to just say, we can just use simple multiplication here. I know that there's 60 seconds per minute. And a lot of us just want to say right off the bat, go ahead and just multiply 60 times 100 and you're going to get your answer. Do me a favor and pay attention to this example, how we're doing it in this example. Pay attention to how they show it in the book on page 344 and get in the habit of doing this method. If you can master this method now, you'll be in great shape when you get to high school and you're doing chemistry. What we're going to do is, first of all, I'm going to point out that I'm starting with what they gave me. This was given 100 times 100 lightning strikes per 1 second. But the question is asking me how many times does it strike, not per second, but per minute. So somehow I want to point out that this unit does not change. It's this unit that does. So what I want to do is I want to multiply this by a number for 1, because I can't change the amount, the rate that lightning strikes. I want to multiply this by the number of 1 so that this value doesn't change, but the name of it does. Okay? So I'm going to set this up very sneakily. Remember, I know that there's 60 seconds for every 1 minute. And if I remember this, I should understand then that I could divide 60 seconds by 1 minute and I would get 1. All right. And that's what I'm going to do. I'm going to put 60 seconds on the top, and there's a reason why I'm putting 60 seconds on the top. And I'm going to put 1 minute on the bottom. And then I'm going to do some multiplication. But before I do that, I'm going to do some simplifying as well. Now, in addition to simplifying numbers, Now, normally I would say, is there a common factor that goes with a numerator and a denominator? Both of these denominators are 1, so there's not really any simplifying that I can really do. But if I know I want to end in minutes, I'm going to put minutes on the bottom where it's supposed to be, and I'm going to set it up so that seconds is on top and able to cancel out with the seconds that I already had. So this unit actually can cross out just like we would common factors. Now all I have is 100 over 1 times 60 over 1, but it's 1 minute, okay? I'm going to do the denominators first because that's easy. 1 times 1 minute, 1 minute, okay? And up here, I'm left with 100 times 60. The only unit I have left is times, so that's why it ended up over here. I'm going to multiply 100 times 60. Well, that's 1 times 6 with 1, 2, 3 zeros. And I know that lightning is going to strike 6,000 times per minute. And so that's how I convert it. I'm going to find out what my unit wants to end in. I'm going to set it up so that that unit's going to survive. And it's going to cancel out. I'm going to set it up so it cancels out the unit that I want to get rid of. That's how I do it. Now, like I said, I'm going to go back to the unit rates. A unit rate is a rate with a denominator of 1. So if I go back to these guys again, you can just kind of see what I meant when I said these maybe would have been better examples for that. Because both of these have denominators of 1, 35 miles per 1 hour, $1.89 per 1 gallon of gas. But it's still a rate nonetheless. It's just specifically a unit rate. In example 3, I'm given a situation in which it doesn't really tell me what it is. It says write negative 24 feet per 5 seconds as a unit rate. So maybe you drop something into the lake and it's traveling 24, it's sinking 24 feet every 5 seconds. I want to know how many feet per 1 second that is. And here's how I'm going to do this. Notice I've got this set up. This is what they gave me. It says negative 24 feet per every 5 seconds. I set this up as a ratio. And then I set it up again. I know it looks like I did the exact same thing. Well, that's because I did. But what I want to do is I want to change this guy to be 1. And I have to use division to do so. So I'm going to use division. I'm going to divide the bottom by 5. And we all know that whenever I do to the bottom of a fraction, the denominator of a fraction, I've got to do the same thing to my numerator. So I'm going to divide the numerator by 5 as well. And that one might not be quite as pretty as this one down here, but that's okay. When I divide this out, I'm going to do the bottom first because that's easier. 5 divided by 5, I get 1 second. And then on the top, I have negative 24 feet divided by 5. And go ahead and punch that in the calculator if you'd like. I'll clear all this stuff out. Negative 24 divided by 5, and I get negative 4.8. And that's the unit survives, so it's going to be negative 4.8 feet per second. And there's my unit rate for that scenario. So go ahead, and I encourage you to go back and look at some of those examples again. You have the video, so you can always go back and look. Remember that your homework is found on page 345. Please do numbers 3 through 26. Please take careful note as to what the directions are asking you to do. The first set of directions is just simplifying it, putting it in the simplest form. And then they ask you to do some other things like write any equivalent rates or ratios, and then writing rates as unit rates. So just pay close attention to what the directions are asking. Page 345, numbers 3 through 26. Thank you very much.